All right, so I'm going to talk about the other thing we can do with probabilities, and this is talk about them as being ORs. So again, I'm going to draw my sample space here. Let me get the sample space out, and in that sample space, I'm going to put two events. Sorry, I'm moving my notes about here. And so if this is, whoops. Switch pens again. There we go. This is event A, and this is event B. The probability of event A can be considered the area of the circle, and the probability of event B can be considered the area of the circle. Now, if I have the probability of A or B, what I want to do is I want to add the probabilities. I want to add the area that the probabilities fill in my sample space. Now, notice these events, if A happens, none of the outcomes in A are shared with B. And we call this mutually exclusive. We're saying that the events in A are mutually exclusive to the events in B. And so if either A or B is going to happen, then we look at the addition of the probabilities. So for example, if I need to roll a D8 and roll a D5, or not D5, there are no D5s, it's D6, sorry, I subtracted one. And my probability of rolling a 5 on the D8 and a probability of rolling a 3 on the D6, right? And so those are the two rolls I could possibly do. Well, if I either roll a 5 or roll a 3 on the D6, now whatever I roll on the D8 won't change the sample space for the D6. And so my probability of rolling a 5 on a D8 or a 3 on a D6 is my probabilities. And so this is 1 out of 8 plus 1 out of 6. And so my probability would be, let's see, 6 out of 48 plus 8 out of 48, or 14 out of 48, 7 out of 24. And if I run over to my calculator here and just verify this, let's see, so oops. So 7 divided by 24, it's approximately 0.29. Or 29% probability of rolling either a 5 on a D8 or a 3 on a D6, right? I have either or would happen, not both. And so the probability space is the summation of these. If, for example, I just had a D6 and I did the probability of rolling a 1 on a D6, or rolling a 2 on a D6, or rolling a 3 on a D6, and so on, so that I had all possible outcomes. So the probability of rolling a 1, or a 2, or a 3, or a 4, or a 5, or a 6 on a D6, that would give me 1 6 plus 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 1 6, or 1. My probability of rolling any of the possible outcomes with that or statement in there should cover my sample space. And that gives me the possibility of 100% guaranteed. So ORs, unlike multiplications, the probabilities get bigger. When we OR things, we're actually creating more possible outcomes in our sample space. When we were ANDing things, we created less. If you can think about an AND, when I AND something, A and B, that's one possible result only. But when I do A or B, that's three possible results. That's A or B or both A and B. And so my odds of this happening or is happening should increase. The probability should go up. And the probability should go down. And our multiplication rule did that, and our addition rule is making our probabilities go up. But sometimes our sample space is not nice to us. So or not our sample space, but our events. And so we could have two events, A and B, that share outcomes. They share outcomes that are together. And so we have to add up the area of A and B and then subtract the space where we double count. Right? Double counting is going on in here. And so we call these not mutually exclusive. There's an inclusive nature to these probabilities. And so the probability when the events overlap in the sample space, the probability of A or B when they're not mutually exclusive is the probability of A plus the probability of B minus the probability of A and B, right? Because that's the AND. That ANDs them together. So for example, I'll go back to my die example. The probability of rolling odd on a die or less than 3. Use the example from the book. And so I will draw my probability space for this here. Oops, let me make that bigger. Again, bigger. Get my circles there. All right, so odd numbers are 1, 3, and 5. And then less than 3 is 1 and 2. And they share one outcome. So the probability of odd is 3, 3 out of 6. The probability of less than 3 is 2 out of 6. But the probability of odd and less than 3 is 1 out of 6. And so if I put these all together, I get the probability of odd or less than 3. I have to add the probability of odd plus the probability of less than 3 minus the space that they share. And I get 4/6. Or 2/3, which is approximately 0.667, 66%. And so probability spaces, we can have an OR. I really want to stress, ANDs reduce the number of outcomes you're looking at because you're taking two events or multiple events and you're saying, I need all of them. So I'm really creating this one outcome out of my ANDs. And ORs give you multiple possible outcomes. And so ANDs should be lower probabilities. Multiplying fractions give you smaller numbers. ORs should be higher probabilities. Adding fractions give you larger numbers. We're going to look at this in a little more depth.